Forget traditional crime scenes with physical DNA and muddy footprints. Today, we are tracking ghosts in the machine. Welcome to this explainer, where we're going to completely unmask the invisible methods attackers use to infiltrate networks. We're going to break down the exact step-by-step investigative techniques required to stop them using Douglas Schweitzer's exhaustive incident response playbook as our guide. It's an absolutely fascinating world, so let's just dive right in. To structure our investigation today, we'll follow the cyber detective's journey chapter by chapter. We're starting with the crime scene, then uncovering backdoors and sockets, dissecting Trojan anatomy, opening up the detective tools, eradicating threats, and finally looking at review and the future. All right, Chapter 1, the crime scene. So what actually happens when a digital break-in occurs? Well, unlike a physical burglary where you might come home to a smashed door and a missing TV, a data thief copies your files without actually deleting the originals. To the naked eye, the scene looks completely intact. Nothing is out of place. And that brings us to our foundational tool, computer forensics. Think of this as the art of freezing time on a compromised machine to extract legally sound court-admissible evidence. You see, every single click, every deleted file, or tiny network connection leaves a microscopic digital footprint just waiting to be uncovered by the right detective. Now, look at this real-world data from the FedCirc summary. It is honestly wild. Root compromises make up a massive 26% of reported incidents. In the programming and hacking world, root means having absolute supreme administrator privileges. So in over a quarter of these cases, the attacker didn't just peek through the window. No, they stole the master keys to the entire house, effectively becoming the virtual owner of the machine. Moving on to Chapter 2, backdoors and sockets. How exactly do attackers breach the perimeter to get that terrifying root access? Well, it almost always comes down to a back door. Let's use an analogy. Imagine your computer is a massive skyscraper and it has 65,535 possible doors. In networking, we call these ports. A firewall's job is to heavily padlock the main doors. But a backdoor? That's a tiny hidden basement window that malicious code has quietly unlatched from the inside. The hacker can now enter and exit at will, totally bypassing your heavy-duty front door firewalls. To find these hidden windows, digital detectives absolutely cannot rely on standard graphical interfaces, because those can be manipulated by the hacker to lie to you. Instead, they drop down to concrete command line inputs like netstat-n. This specific command scans the machine and lists all active connections, revealing what are called sockets. A socket is pretty simple. It's just your machine's IP address, permanently combined with a specific port number. So step by step, if the investigator runs this scan and spots a weird, unknown connection sitting there on, say, port 31337, boom, they instantly know a backdoor is wide open. Detectives also hunt for unauthorized user accounts using standard OS tools, like the Windows Computer Management Interface. Once a hacker gets inside, they frequently create ghost accounts equipped with administrative rights so they can easily get back in later. If you're inspecting your user list and you suddenly find a tech_support account that you definitely never authorized, yeah, you've just found the intruder's fingerprint. Let's hit Chapter 3, Trojan anatomy. Okay, so how does the code that opens those backdoors get into your system in the first place? Almost always through Trojan horses. Unlike a classic, noisy computer virus that frantically replicates and destroys everything it touches, a Trojan is entirely stealthy. It masquerades as a harmless application, sometimes even having the audacity to pose as a fake antivirus update. You click it, and while you think you're just installing a game, it silently injects malicious code directly into your system's memory in the background, quietly unlatching those hidden network ports we just talked about. The danger here is absolutely absolute. Once deployed, malicious programs with names like Backwurfis or Sub7 grant the hacker terrifying step-by-step control over your machine. We're talking about the ability to view your screen exactly as you see it live. They can log every single keystroke. That means they capture your hidden passwords the exact second you type them into your online banking portal. It is pure, unfiltered digital espionage. Chapter 4, Detective Tools. Faced with these stealthy threats, the detective basically has two choices. They can meticulously assemble a DIY toolkit using various command line freeware utilities, which demands immense technical expertise. Or they can rely on prefabricated powerhouses. Tools like the Coroner's Toolkit are the absolute gold standard for dissecting compromised Unix systems, while Access Data's Forensic Toolkit completely dominates the Windows environment. Crucially, these tools allow the investigator to clone hard drives bit by bit.
This ensures they can rip apart the system for clues without ever altering the legally admissible original evidence. But you know what? Sometimes analyzing a dead, static hard drive just isn't enough. That's where packet sniffing comes in. Think of this as the digital equivalent of wiretapping a phone line. Data on the internet doesn't travel in one giant solid chunk. It's sliced up into millions of tiny pieces called packets. The detective deploys a sniffer on the network to intercept, capture, and reassemble these invisible packets in real time. It literally allows them to hear exactly what the hacker is whispering to your machine right at that moment.
And listen, this isn't like the hacker movies with flashing 3D graphics and neon skulls. It is raw, austere, text-based data. By analyzing the raw HTML extracted directly from a captured packet, investigators can painstakingly sift through the noise to find the smoking gun. They're looking for hidden commands, foreign IP addresses, or illicit files actively in transit. It's a meticulous, intense search for the truth hidden right there in plain text.
Chapter 5. Eradicating the threats. Every professional incident response investigation relies on a rigorous 6-phase cycle. You can't just panic and randomly yank the power cord out of a server. You must prepare for the incident, accurately identify the true nature of the Trojan, contain the bleeding, completely eradicate the root vulnerability, carefully recover your operations, and finally, follow up to ensure the loop is closed forever. The most delicate phase of this entire process is containment. When a hacker is actively navigating your network, you face a massive tactical dilemma. Do you instantly sever the internet connection to lock them out, knowing full well that you are alerting them that they've been discovered? Or do you maintain operations to silently monitor them and build a bulletproof legal case? Whatever strategic choice you make, immediately changing all compromised passwords is a non-negotiable first step. Finally, Chapter 6, Review and the Future. One of the greatest lessons from the field is that disaster recovery planning can no longer just be about a server crashing or a building catching fire. Backups are no longer just dusty archives. They are your ultimate security countermeasures. But there is a huge catch here. Reinstalling a backup that contains a dormant Trojan will simply restart the nightmare all over again. Your backups absolutely must be forensically sterilized and verified before you hit restore. Modern attack tools are meticulously designed to be totally invisible and completely silent, carving out backdoors in the deepest architecture of your systems. So, the next time you boot up your computer, I want you to ask yourself, do you truly know who is currently connected to your open ports, hiding in the silent traffic of your own network right now? Stay curious and stay vigilant. Thanks for joining me on this explainer.